All right, so I've been getting a lot of questions about the ignition that I've been building. To start, I guess it's not actually an ignition. So let's talk about that. This is the quote-unquote brain. Okay, this is a board that I've designed. It's based on what's a system called Speeduino. It's an open source engine management system. It's very similar to Megasquirt, if you ever looked at that. But a completely different software, but conceptually it's the same as Megasquirt. So basically I started with a reference design for a Arduino, which is what Speeduino is based on, and then added on a lot of circuitry for the Speeduino engine controller. This is a prototype board. This is my third revision, I believe. I've got a ton of test circuitry on here, trying to clean up signals. Most of what I've been fighting with this is noise, right? Noise, AC noise in the start-stop circuit and the crank trigger input and stuff like that. So I've got most of that dialed in. I got a lot of that figured out. Mostly Zener diodes solved that problem, interestingly. So that's that. As you can see, this is just a bare board right now with a header soldered on. This is an amp connector, 23 pin. Probably I think about 10 of the pins aren't used, so there's plenty of room for expansion. There's plenty of I/O left that I'm not even using, so lots of opportunity to add on if you wanted to. So going outside of that, there's a couple other components. To start with, the crank trigger is probably the most important aspect of an ignition system in general, but specifically this one. This is a Hall effect sensor that I'm using. This is arguably more expensive type that does not need magnets for triggers, right? This can just use ferrous metal, which is what this trigger wheel is. So this is a pretty standard sensor. This is used in a lot of different things. This is a 5505. I think it's a Little Fuse. Who makes this. There's the part number for anybody who wants to copy this. So it's a 3-wire. This actually mounts in front of the flywheel. So you'll see, let me just show you right on the ski here. There's where it's mounted. This is a prototype front cover that I've just basically tack welded that on and epoxied it in. But it's basically a little adapter that I've milled out, and it's in a CNC'd out, and it goes right on top of a front cover, a normal stock front cover, and it positions the pickup or the crank trigger. So that's the Hall effect sensor. And this is the wheel that's inside there. I've gone through a couple different iterations on this. Originally started with a 60-tooth flywheel. That was way too much precision at a 3.5-inch diameter. I've mostly been working with a 36-tooth, 36-2 trigger wheel, which is a 36-tooth wheel with 2 teeth missing. But recently I've switched to a 12-1. So this has 12 teeth. Well, it would have 12 teeth, except one is missing. And this is the index, basically. It tells the system where top dead center is, more or less. So that mounts, if you can imagine, this is a 760 flywheel, so this is the front. But this sits right in front, okay? And then this is somewhere up here, okay? And that's pretty much all there is to it. It's really simple. The air gap here is kind of critical, so it's kind of difficult to get that. Well, it's not difficult to get that dialed in, but it's something that's going to need adjustment on each individual ski. The other thing that's a little tricky about this is not indexed in any way, so it's kind of on the installer to set up, to find top dead center, and then align this with the sensor and set timing with a timing light and adjust basically the offset to get it just right. So once it's set, no big deal. And I've been drilling a little hole just so I don't have to mess with it again. I usually drill a little hole somewhere here and somewhere here in the flywheel, and just put a roll pin in to hold it in position. So that's the crank trigger. So moving on the other side of the ECU, we've got coils. Okay, so these are what are called IGN 1A coils. They originally come from a Mercury outboard 2-stroke engine. They're designed for 2 strokes. These are not CDI, okay? These are smart coils. Let me start with that. So the driver for this, what actually powers these coils, is inside the coil. Okay, you can see there's a heat sink here. All the circuitry is in there that drives the coil. Typically, like on an MSD, that's all built into the brain, and the coils are just what they call dumb coils. They're just 2 windings, basically, which increase voltage. Okay, so this is a smart coil. It's got all the windings to increase the voltage to 30,000, 40,000, whatever it is, volts. But it also has the driver. So it really simplifies things. But with that, these coils take a lot of power. So, you know, I basically need a relay to power them, because if you're running as the max dwell on these at high RPM for a long period of time, you can pull as much as, like, I want to say 10 amps per coil, although I haven't seen anywhere near that. This is a crazy overkill cheapo relay I've been using just for testing, but I have to explore better options there. But basically the ignition controls this relay. When the ignition is on, it will power this relay, which powers the coils. Pretty simple. So that is that. So that's actually pretty much it. If you're familiar with MSD, one of the things that's annoying is you have to hold the stop button to stop the ski, or you have to run a shifty module, which is basically a latching relay. What's called a latching relay. This does not need that. Similar to like Zeal or others, there is solid state latching circuitry in here. Basically, there's you can actually, I put the circuit out, the schematic out there for everyone to look at on the X, but there's a solid state latching circuit in here, which is around this area. So that's it. When it's off, it draws next to nothing. It does draw a tiny amount of power when it's off, but probably less than every other ignition on the planet. So there's that. As I mentioned, this is just exposed right now. This is intended to go in this case or a similar case that I've had made. It's actually 3D printed, but in China. This will go in here and get potted in potting epoxy. So you'll see if you're not sure what a potting epoxy is. I think my original ignition's around here somewhere. There it is. That's potting epoxy. Okay, it's just basically an epoxy that's made for electronics. Has a couple different characteristics than versus normal epoxy, where it can dissipate heat pretty well and stuff like that. So that makes it waterproof, makes it safe to use in a jet ski and all that stuff. So that's pretty much it. Definitely let me know what questions you have, comments, feedback, etc. The other thing which I didn't mention is there's 2 general purpose inputs and 2 general purpose outputs on this. So you can control anything you want up to 2 amps. Basically, I'm going to use it for water valves to control water injection at different RPMs. You could use it to control, you know, any number of things, power valves, whatever. There's 2 general purpose inputs. You could read pipe temperature, exhaust temperature. You could do add circuitry for a wideband. You could use a throttle position sensor, intake air temperature, just you name it. And it's all, you can data log it all. You can, you know, tune it all on the fly. This is all tuned. It's commonly tuned with what's it called? Megatune? That's not the name, but the commonly available software for Tuner Studio, which everybody uses for a bunch of different ECUs. You can also get an app for an Android device and connect to this via Bluetooth, which is really cool, and you can data log via Bluetooth. So you can stick a cheap Android phone in your pocket or strap it in your hull somewhere and ride the jet ski and data log via Bluetooth while you're riding. And you know, nobody's data logging on these jet skis, which I think is something we're really missing. Anyway, that's it. Let me know what questions you got. See ya.